Hello. Today I'm going to be doing a calculus, um, almost like ASMR type. So we'll see how everything goes. So for my calculus, I actually do have a quiz today. And what I'm going to be studying is the disk method and the shell method, which is to find the volume of the shape, I guess, by the two, formed by the two functions. And then I might be quizzed on the fact that I need to find the area of a graph, which is more simpler. So there are a couple of formulas that I need to go over, and the first of which is the area between two curves. So the area between two curves, if we go back to our notes, I believe yes. So starting from section 1.7.1, the equation is simply the area is equal to the integral of a to b f of x of d of x, or dx, as some people would say, or most people would say. Yeah, so that would simply be the area. However, if you want to find the area between two curves, you have to use a slightly different formula, which is the integral of a to b f of x minus g of x dx, which states that f of x is one function, and then you're subtracting the other function. So usually the positive function would be on the top. So for instance, if you were to look here, the top curve, the top function is that one. The bottom function is this one. So the top one minus the bottom one, and then doing the integral of that gives us the answer, which is the area that's between the two curves. So let's write that down really quickly. So the area equals the integral of a to b, which means that it's going to be f of x minus g of x dx. We can't forget about that. So that's the first formula. The second formula is the disk method. Now, the disk method involves the use of pi, because we're trying to find the volume, so it needs to be in a full 360 degrees, which is why pi is involved. And the formula for that is simple. It's the volume equals pi, the integral from a to b again of f of x. However, now the f of x is going to be squared. So f of x squared dx. Now that's the second. The third formula is for the shell method. The shell method is going to be a little bit more complicated, not too much complicated. It starts off with the volume is equal to 2 pi, the integral from a to b again, of f of yes, I believe it was the h of x, correct? Yes, the h of x, which is the height of the position x, and the positioning of the curve, essentially. The position of where the shape is going to be, which it could either be on the x-axis or the y-axis, dx. And they will be multiplying with each other. So this is the formula that we have right now. Okay. So I know that the harder, the more difficult problems will be from 7.3. So what I'm gonna do is, instead of starting from 7.1, I'm gonna straight up go to 7.3 and then start the exercises from the homework. So going to 7.3, I believe 7.3, we don't have much homeworks, but we still do have homeworks, which is why we will be redoing them. So the homeworks are ranging from 3 to 6, everything, odd and even, and then 15 and 16. So 3 to 6 is odd / even, and then 15, 16. Perfect. Let's start with that for now. So, going to problem 3, I have my handy laptop to perfectly help me with this. And I recently switched to the Apple ecosystem, so I got an Apple phone, Apple iPad, Apple everything. But I like it so far. It's pretty nice. Used to be a pretty big Samsung fan. I mean, I still am a pretty big Samsung fan because I love the innovations that they come up with. But Apple's ecosystem is quite remarkable, and their software is quite, everything works really well. So, but going back into the problem. So problem 3 states that we need to use the shell method to write and evaluate the indefinite integral. It's going to represent the volume of the solid generated by revolving the plane region about the y-axis. So if it's going to be about the y-axis, the first function that they give us is y is equal to x. So from what I can assume, if y is equal to x, then the integral we simply just need to set the integral from, so looking at the graph specifically, we can find that the height of the function, because it's y is equal to x, is from the y-axis. Because of that, we know that the height starts from 0 and then ends at 2. Now that we know the height, which is going to be the bounds of the integral, we move on to the function, which is y is equal to x. So inside of the function, we simply put x. And what is x being multiplied by? Well, if we're going about the y-axis, if we're going to be folding that area around the y-axis, right? Because it is a volume, it's not an area. So if we're folding it around the y-axis, what we need to do is we need to set the positioning by the x-axis. So what this turns out to be is the volume is equal to 2 pi from 0 to 2 multiplied by the height, the function, which is x, times the positioning, which is also x, and then we add a dx. So let's do the integral really quickly. So it turns out to be 2 pi, the integral of 0 to 2, x squared dx. Now the integral of x squared is quite simple. In this case, it would just be x to the power of 3 over 3 dx. And that turns out to be from 2 to 0. So now we need to apply the definite integral 2. We don't need to worry about 0 because it's nothing at 0. So applying 2 to the power of 3 is 8. So 2 to the power of 3 is 8 divided by 3. So we just keep it as a fraction, 8 over 3. Right? We still need to multiply by 2 pi, so we add that to the function, which turns into 16 over 3 pi. And there we go. That's the first problem out of the way. So that's 3. Let's do 4 really quickly as well. So 4 states that y is equal to 1 minus x. Now if y is equal to 1 minus x, it seems as if it's almost descending, right? So we can apply the same formula. Volume is equal to 2 pi. Now we need to find the height. So it's going from 0 to 1. It's still rotating about the y-axis, which means that if it's going from 0 to 1, then that should be our bounds, our 2 bounds. And then from the function, it is 1 minus x, and then you multiply the function by the positioning, and it's still going by the x-axis. So we multiply that by the x dx. Now I would like to check just to make sure I'm doing this correctly. Oh, perfect. Yes. Fairly simple. So, continuing with this, we multiplied 2 pi times, before we even multiply that, let's just multiply the functions first. So x is going to multiply to 1, which turns that into x, minus x times x, which is x squared. Now, we have the full function, 2 pi. So now the simplified version is 2 pi, integral from 0 to 1, and the function inside is x minus x squared dx. Now we still haven't integrated, so we can simply integrate this. Because it's a subtraction in the middle, we can say that x squared over 2 minus x to the power of 3 over 3, and there we go. That's the integration. And that's going to be from 1 to 0, and then we're going to have 2 pi on the outside. So applying the 1, so 1 squared is 1, over 2 is 1/2, minus 1 to the power of 3, which is still 1, over 3. So that gives us 1/3. So it's 1/2 minus 1/3 times 2 pi. Now we should probably do some simple, substitution, or simplifying the fraction by finding the common denominator by realizing that the common denominator is 6. So 1/2 turns to 3 over 6 minus 2 over 6 for 1 over 3. And then that gives us 2 pi 1 over 6, which is also 1/3 pi. Then that is our answer for number 4. Number 5 is y is equal to pi square root of x. There's no pi. So y is equal to square root of x is our equation. Let's set up the problem again. So volume is equal to 2 pi, the integral of, so now let's find out where the integral lies. So for this specific problem, the integral is from 0 to 2. So we just apply that. And then it seems as though it is still rotating about the x-axis. So what we need to do is apply the function, which is square root of x, and then multiply that by x dx. That should be the correct answer. Let me just make sure yet again. I would like to be correct. Okay, perfect. It seemed a little bit too simple for my liking. So now, whoa. Okay. So going back into this, we have 2 pi on the outside. Let's just keep it out there for now. And then we multiply each of them. So we have to do the integration. So the integral of x, or square root of x, is simply, we need to turn that into a, almost like a square root fraction. So it would turn out to be x to the power of 1/2 because it's a positive square root. If it was on the denominator, it would be a negative square root. But it would be x to the 1/2. So the integration of that is simply adding 1. So it's going to be 3 over 2 over 3 over 2. So that turns out to be, and then let me just write this down really quickly. So it turns out to be 2 pi, multiply that by 2/3 x to the power of 3 over 2. And then you multiply that by x to the power of 2 over 2. From 2 to 0. Okay, so now that we have that, what we can do is apply 2. So 2 to the power of 3 is, 2 to the power of 3 over 2 is going to be, oh man, I don't want to do long division for fractions. Okay, you know what, I'm just going to use a calculator for this one. Let's go to my calculator. So 2 to the power of, or actually it's going to be 2 over 3 times x, which is now actually 2. So 2 to the power of 3 over 2, which gives us roughly I wanted like a definite answer. However, it's giving me a bit of a interesting answer, which means that I'm probably going to leave this problem unsimplified. It looks like it's going to be 4 times 2 to the 1/2 over 3. And then applying 2 to the power of 2 is simply 4 divided by 2 is 2. So we put that, which turns out to be 4 pi 4 times 2 to the 1/2 over 3. And there we go. That's the answer for number 5. Go to number 6. So number 6 is, oh, this one's a little bit more interesting. So number 6 is y is equal to 1/2 x to the power 2 plus 1. So the graph that they're showing us is a little bit different because of the fact that the function is on the bottom. Normally the function is on the top. And because of that, we wouldn't have to necessarily worry. However, in this situation, what we need to do, let's set up the function again, which is volume is equal to 2 pi. The integral from, now the integral is looking like 3 to 1, right? So it's going to be from 3 to 1, those are the bounds. And then it appears to be, it appears that the top of the area, the top of the volume is 3. So we set 3 in the function, subtracting the actual function, which is going to form that specific shape. So 3 minus the function, which is 1/2 x to the power of 2 plus 1, and then we multiply that by x, because it is still revolving around the it's revolving around the y-axis. And let me make sure if it's correct. I would like to confirm such a problem. And yep, it looks like we're correct. So I'm just going back to my previous problems that I've solved just in case. So doing the same thing, we have 2 pi, integral from 1 to 3. Now I would like to integrate this, so it would be 3x minus, so now this one has a fraction. So what I'm going to do is, if it's 1/2 x to the power of 3, what I can simply do is 1/2, actually it's going to be x to the power of 3 over 3, right? But then in this case, it would be x to the power of 3 over 6, because the denominators are being multiplied, plus x times x dx. So going on from that, we still have 2 pi. We have integrated, but we still need to multiply the outside. So if we can multiply the outside, it's going to be 3x squared minus x to the power of 4 over 6, I believe 6x, or maybe, I think it's just 6, plus x squared dx. So now that we have that, we need to include the bounds, which is from 1 to 3. So once we have that, should be, I would like to make sure this one's correct. Oh no, so it is on the bottom as well. Okay, makes sense. So it's actually 3x squared minus x to the 4th over 6x plus x squared. Bounds are from 3 to 1, which means we're going to be applying the function. So if we're applying, whoa, why is my, okay, I'm having a little bit of a scatter problem. Okay, so going back to this, yes, okay, we're good. I keep worrying that, like, I might be missing something, but it looks fine. So it's gonna be 2 pi 3x squared, so we apply 3, which is gonna be 9 times 3, which is 27, minus x to the power 4, so that's 3 to the power 4, which is 27 times 3, which is 81. 81 over 6 times 3, which is 18, plus x squared, which is 3 squared, which is 9. So I believe 18 over 81. 81 over 18, so that's 9 over 2, correct? I believe that it could be simplified. 81 divided by 18. No, I can't do that. 4 1/2. Okay. Yeah, so it is 9 over 2. Okay. But before we do that, let's multiply the 2. So we're gonna be left with pi times 54 minus 81, which is times 2, which is 162. 162 over 18 plus 9. Now 182 over 16 should give us a whole number, I believe, and it gives us a 9. Oh, whoops, there's need to be 18. There we go. So it gives us pi times 54 minus 9 plus 18, which in this case is simply pi times 54 minus 9 plus 18. So 54 plus 8 plus 9, which is simply 63. So there we go. So it's 63 pi for problem 6. Moving on to problem 15, we have we have another graph which shows us that y is equal to 1 over x. Now, y is equal to 1 over x, meaning that we need to worry about the way that the graph is positioned, because it is not right next to the y-axis. It is actually one block away from the y-axis. So we need to essentially subtract 1 in the future, I believe. And there seems to be 2 different integrals. So what we can do is we need to find the first integral, which is from height 1 to 1/2. So the volume is equal to 2 pi from, so there's going to be 2 separate integrals in problem 15. The first integral is from 1/2 to 1. The function is 1 over x. Multiply that by (1 minus x). I believe this is the proper function, because we need to subtract 1 from the function x. I believe that's, or it could make sense that it would be x minus 1. Oops. Okay. So from what it looks like, I set x is equal to 1 over y, which I'm not entirely sure why I did that, because I think at the end of the day I still would have gotten the same problem, or the same answer. So the answer that I got before was 1 over 2 pi, which, okay, I see how I got that. So everything looks to be the same, but it's in terms of y. So if we go back to our problem, I said that the positioning should be subtracted by 1, or 1 should be subtracted from the positioning, which is not true. I believe the correct way to solve this is by subtracting 1 from the function. So if the function is 1 over x, we subtract 1 from that, and then we just multiply by the x dx, and then we add another integral. So the integral now is going to go from 0 to 1/2, which, don't forget, we still needed to add a 2 pi, and the function inside is simply going to be y, or in this case x, because there's no function that's above it. The range is from 0 to 1/2, and the area that's inside it is simply the x, which means that the volume now equals, for the first integral, it's going to be 2 pi, and then if we this is going to be x to the negative 1, which means if we turn x to the negative 1, the integral of that, it's going to be x to the, that one's a little bit confusing, because it seems that it turns into a positive, which doesn't necessarily make sense. So let's see what I did here. So y to the so 1 over y simply turns into 1. Okay, interesting. I didn't know that it would turn out this way, or maybe that's not true. Oh, okay, I see what I did. I forgot. Okay, let me just multiply the x first. We need to so we still have the integral from 1/2 to 1, we multiply x. So x over x gives us 1. Minus 1, which if we multiply x2, is going to give us x. So it's going to be 1 minus x plus 2 pi, the integral from 0 to 1/2, and then we'll just keep that as an x. We don't need to do anything about that. So now we do the integral. So the integral from 1/2 to 1 is going to be x minus x squared over 2 from 0 to 1, or 1/2 to 1. And then we add that to 2 pi x to the power of 2 over 2 from 0 to 1/2. Now that we have two of the definite integrals, we simply need to apply the numbers, and we will get 1 minus 1/2 to the power of 2, which I believe is 0.25. I wish my calculator has battery, but it doesn't. Yeah, so it's going to be 1/2 to the power of 2 divided by 2, which would turn out to be 1 over 8, right? 1 over 4 divided by 2. This should give us 1 over 8. Yeah. Okay, so 1 over 8. Wait, what am I doing? Okay, I mixed two of the bounds together. So 1 over 2 is 1 over 2 is 1 over 2. It's a little bit confusing with all these fractions. And then we subtract that by 1/2 yeah, we subtract that by 1/2, and then 1/2 minus, or maybe in this case it would be plus. Yeah, in this case it would be plus 1 over 8. So if that's the case, then what we need to do is simplify them and add them together. Let's do the other one real quick though. So 1/2 to the power of 2, oh, that's going to be 1 over 8. So there we go for the other one. So simplifying this together, which will turn out to be, so we can do it in terms of 8. So it'll be 2 pi 8 over 8 minus 4 over 8 minus 4 over 8, which cancels everything out, plus 1 over 8, which is actually pretty simple. It's 2 pi 1 over 8 plus 2 pi 1 over 8, which means that it will turn out to be well, it's going to be 4 times 2 over 8, which means it's going to be 8 over 8. So I believe it's just pi. 2 pi is the answer, I believe. But we'll see. We'll see. I think 2 pi is legitimately the answer. Whoops. Okay, so they got 1 over 8, 1 over 2 pi. Maybe I did do something wrong. Okay, so 2 times 1 over 8, which gives us 1 over 4 pi plus 1 over 4 pi. Oh, okay. Okay, so then that'll be 1/2 pi. Okay, so no, it is 1/2 pi. So, okay, so this does work out, which is very nice. And now we go to problem 16. So my Calc 2 class is in approximately 2 hours, and I've already almost, I'm like more than halfway finished to the shell method. The disk method is even quicker, way quicker. So that'll be really, it'll be quite easy. And then finally the easiest one, which is going to be finding the area between the two curves. And there we go. So let's do number 16, which is Number 16 is x plus y squared plus 4. Sorry, x plus y squared equals 4. Now, how do we put this in terms of y? Now, in order to put this in terms of y, we simply have to subtract the x, which means that it'll be y squared is equal to 4 minus x, and then y is equal to square root of 4 minus x. So we have what seems to be our y equals, and the volume is going to be 2 pi from 0 to 2, which is going to be the function times the positioning, which is quite simple. In this case, it's going to be so in this case, it's going to be the square root 4 minus x, multiply that by x. Yeah, looks pretty simple. Let's see if it is. So we get 2 pi from the integral of 0 to 2. So now the integral, so we can actually, let's do the integral first. That seems to be easier. So in order to do the integral, it's going to be squared, I believe, x to the power of 2. This is interesting. Maybe if we don't necessarily. Okay, so if we're going to find the integral of something like this, then we're going to have to do 4 minus x to the 1/2, which means that it will turn into 2 pi. If it's going to be to the power, we're going to add 1 to 1/2. It's going to be the same thing as before, which is going to be 2/3 multiplied by 4 minus x to the power of 3 over 2. And then the x will be x over 2 over 2 from 2 to 0. Now, if we apply the boundary, which is simply just 2, it's going to be 2 pi, multiply that by 4 minus 2 is just 2, so it's going to be 2/3 multiply that by 2 to the power of 3 over 2 times 2 squared, which is 4 over 2, is 2, which gives us to 4 pi times 2 over 3 to the power, or 2 to the power of 3 over 2, which should give us the correct answer. Let me make sure. So 2 to the power of 3 over 2 well, I would like to, okay, let me go to a different website. Two to the power of 3 to the power of 1.5, basically. To the power of 1.5 times 2 over 3. Right. times, let me just put a parentheses. 2 over 3. Whoa. No. Went back to. Ah, crap. 2 to the power of 1.5. Multiply that by 2 divided by 3 times 4. What? Why does it keep going back to the previous? 2 to the power of 3 over 2. Multiply that by. Okay, so that gives us 1.88. Okay, so 1.88. So 1.88 multiply that by 4 gives us 7.52 pi. Which in this case is not correct because okay, so the answer that they got was a lot simpler, which is simply 8 pi, which means that I might have done something incorrect. Y squared is equal to the square root of 4 minus x, correct? I believe that was what it should have been. Okay, this is it's interesting. I guess, you know what? In order to make it simpler, I'll just put it in terms of x, because of the fact that we are rotating towards the. We could simply use any function, but I'm going to go with setting it equal to x because of the fact that it just looks easier, which means that x is equal to 4 minus y squared. So now that we're setting in terms of y, we need to set the boundaries, which is going to be the same thing from 0 to 2. But now we're going to be rotating towards towards the x-axis, which means we set it in terms of y, so the function is going to be 4 minus y squared, multiply that by y dy. This way we don't have to deal with the square root issue. Okay, now we know that if there is a problem with square roots, which is going to be the main function, if I can put it in terms of another function, it probably is a lot easier. 0 to 2, so this will be 4y minus y to the power of 3, because I multiplied the y from the positioning to the function dy. Now we actually do the integral. Oh, this is so much easier. So 4y to the power of 2 over 2, which is simply 2y squared, minus y to the power of 4 over 4 from 2 to 0. So applying the definite integrals, 2 to the power of 2 is 4, 4 times 2 is 8, minus 2 to the power of 4 is 16 divided by 4 is 4. And just like that, 8 minus 4 is 4, times 2 is 8. And there we go. 8 pi becomes our answer. Super clean, super simple. Way more easy than the function. Which means I have to remember that if it's rotating from the x, we set it in terms of x if it's rotating through the x. But if it's if it's rotating throughout the y-axis, we set it in terms of x. But if we rotate it throughout the x-axis, we set it in terms of y. Yeah. Okay, just getting a little bit confused over that. All right, there we go. So we finished 3 to 6 and 15 and 16. Perfect. Let's move on to the next set of problems. It's going to be a little bit more from 7.3. Just a little more. So if we go back to our homework, we have 4 more problems, which is 23, 25, 29, and 31 for 7.3, which is not too bad. So 7.3, 23, 25, 29, and 31. So let's do that without any further delay. So 23 seems to be y is equal to 2x minus x squared when y is set to 0, about the x-axis, x is equal to 4. Okay. Let me write that down really quickly. Y is equal to 2x minus x squared. And then y is equal to 0. And then it's going to be about the x line. The line is going to be x is equal to 4. So the line means that we're going to be flipping it through the y-axis, I believe. So if we were to graph something like this, it would be so we know that the line that we're going to be rotating is going to be 4. There is no function on the bottom because it's the positioning is y is equal to 0, and then 2x minus x squared is going to be I believe it's going to be some it's going to be like a downward parabola. Downward parabola. Got it. So it's going to be a downward parabola. Okay, perfect. So we know that we know what that is. So if we were to set 2x minus x squared is equal to 0, then we should be able to find out the intercepts. In this case, it would be x on the outside, 2 minus x, which would equal to 0, which would mean x is equal to 0 and 2. And that makes sense because it's the exact graph that we have. 0 is right here, and then 2 is right there. It's a little bit of a bad 2, but so now that we have the intercepts, we should be able to calculate the problem. And remember, this is 4, not -4. I'm just pointing an arrow, but it's going to be turning across the y-axis, which means we're going to be setting it in terms of x. So the volume is equal to 2 pi, the integral from 0, and I believe the height is going to be 2 So 0 to 2, and then the function is going to be 2x minus x squared. And then we're going to multiply it by the positioning, which is going to be, in terms of x, dx. Now let me verify, just to make sure that I am correct. I don't want to be incorrect. So oh, right. Okay, I have a slight issue. The slight issue is the fact that there's actually a gap between, there's a gap between the what we're turning in, because remember, this is gonna be like essentially like, you know, going all the way around, but there's a gap in the middle. You see, there's a small gap in the middle. We need to get rid of that gap. So there's 2 on one side and then 2 on the other side. So well, we need to subtract the positioning. We need to subtract 4 minus x. Yeah, we need to subtract 4 because it's a positive from the x dx. Perfect. So if that's the case, we know that it's 2 pi. The integral is going to be 2x to the power of 2 over 2, which is going to be simply x to the power of 2 minus x to the power of 3 over 3. Multiply that by 4x minus x to the power of 2 over 2, ranging from 0 to 2, 2 pi x to the power of 2. So that's going to be 4 minus 8 over 3. Multiply that by 8 minus 2 over 2, 4, 2, so 8 minus 2. Which means that it's going to be 2 pi 4 minus 8 over 3 times 6, which is also 12 pi. Multiply that by 4 minus 8 over 3, which we can also set that into in terms of 3, which means that 4 is going to be 12 over 12, so 12 pi, and then 12 over 3, not 12 over 12, 12 over 3, minus 8 over 3, which gives us 4 over 3, so it's going to be 12, or maybe it's going to be 13 1/3 pi. There we go. I believe that's the correct answer. Okay, maybe that's not the correct answer. Oh, that's why. I did a simple mistake, which is the fact that I did not multiply. See, I simply added, but here it's a multiplication from one function to the other, which means that I need to properly multiply them. So in this case, it would be 2 pi, so 32 first, -8, inner, which is going to be 64 over 3, and then plus 16 over 3. Got it. This should be the correct. So 32 minus 8 is going to give us 24, minus 64 over 3 plus 16 over 3. So that's going to be giving us a 16. 48. I believe it's going to be minus 48 over 3. 48 divided by 3 is roughly, what is 48 divided by 3? 30, so 10, 16, I believe. So 24 minus 16, right? 8, 16, 24, so that's going to be 8. times 2 pi is going to be 16 pi. That should be the correct answer. No, it's slightly incorrect. Because from what it looks like, the correct answer is 8 pi. And I got 16 pi somehow. 3 times 10 is 30. That gives us 18. So 3, 6, 9, 12, 15, 18, that's 16. 24 minus 16 is 8. I'm just a little bit confused on what I could have gotten wrong. Maybe I should have done the multiplication on the top. Let me just do that really quickly. Yeah, I think that could have been a partial issue. Which means before even integrating, I need to multiply by each other. Or multiply the two functions. So first is going to be it's going to be 2 pi, the integral of 0 to 2. So 2x times 4 is 8x minus 2x to the power 2 minus 4x squared plus x to the power 3. There we go. So that should be the correct times dx, correct function. Let me just make sure one more time. Okay, and then positive x to the power. Yeah, that looks good. Looks good to me. So 2 pi, and then now we integrate. So it's going to be 8x to the power of 2 over 2 minus 2x to the power of, 2x to the power of 3 over 3 minus 4x to the power of 3 over 3 plus x to the power of 4 over 4, ranging from 2 to 0. And just like that, if we apply 2 to the power of 2, it's going to give us 4 times 8 is 4 times 8 is 32, divided by 2 is 16. So 2 pi 16 minus 2 to the power of 3, which is 8, times 2 is 16 over 3, minus 2 to the power of 3 is 8 again, times 4, which means it's 32 over 3, plus 2 to the power of 4, which is 16, divided by 4, which is 4. So we are left with this simple answer, which means that it's going to give us 2 pi 20 minus 20 minus 48 over 3, which is also 16. So it's going to be 2 pi 20 minus 16, which is 4, and there we go, 8 pi. Okay, that is a lot better. I'm gonna make this a little bit smaller because I did end up taking a lot of space for this problem. Or maybe I could just move it around. There we go. Perfect. So now we have 25 completed. Let's do 29 or 25. So once I finish this, I think I'll just end the video because it's more than an hour already that I've recorded for. So let me do that. 25 is y is equal to y is equal to 3x minus x squared comma y is equal to x squared about line x is equal to 2. Man. Okay. So let's do the so if it's gonna be x, so now we have two functions. We need to set them equal to each other because y is equal to a specific function and y is equal to another function. So we can set that equal to each other. 3x minus x squared is equal to x squared. So it's going to be 3x minus 2x squared is equal to 0. If we take an x out, this leaves us with 3 minus 2x is equal to 0. X is either 0 or, I believe, 3 over 2. So if that's the case, because it's going to be 6 over 2, which is 3. Yeah, so that makes sense. So now we have the intercepts, which is also going to be the bounds. So the volume is going to be 2 pi from the integral 0 to 3 over 2. Multiply that by 3x minus x squared. However, we need to subtract the bottom function because the top function is 3x minus x squared, but then the bottom function, the bottom area, is also x squared. Because we don't need whatever's underneath here, we need what's inside of this. That's going to be rotating around. So we're going to have to subtract another x squared. Because the original function is 3x minus x squared. With this, it's going to be another minus x squared. Times x, I believe. Because it's rotating about the x-axis. And then dx. Let me verify to check if this problem is accurate. It is accurate. There is a slight change, which means that there is a space which is 2 minus x. Right. Okay, so there's a gap there, so we need to subtract that gap. So that gap is, we don't need that gap, right? So what we need to do is subtract that in the positioning. So 2 minus x dx. Which means that we're gonna have to do cross multiplication again. 2 pi, the integral of 0 to 3 over 2, 3x minus 2x squared, multiply that by 2 minus x dx. Now, the first is going to be 2 pi 2. So the first is going to be 6x minus 3x squared minus 4x squared plus 2x to the power of 3. Doing the integral of this is simply 6x to the power of 2 over 2, which is going to be 3x squared, minus 3x to the power of 3 over 3, which is going to be x to the power of 3, minus 4x to the power of 3 over 3. So this time we can't actually do anything about that, so we'll put it over 3, plus 2x to the power of 4 over 4, which is simply going to be x to the power of 4 over 2. And the bounds are 0 to 3 over 2. Now, applying 3 over 2 to the power of 2, it's gonna be a bit of a pain, but assuming that we put everything, so I'm just gonna put a triple dot, we should be able to get the correct answer, which in this case is 2.81 pi. Because I seriously do not want to deal with applying all of the all the functions and whatnot, so all the fractions. So there we go, we have 25 done. Let's go to 29. And after 29 we have one more problem, which is very, very nice. And that's where I will probably be ending the video. 21 states, in exercises 29 to 32, use the disk method or the shell method to find the volumes, which means that they're going to give us three options. We either pick the disk method or the shell method. So y is equal to x to the power of 3, y is equal to 0, and x is equal to 2. Now let's remember, for a is equal to the x-axis, if we're going to be doing it by the x-axis, we need to set it in terms of y, right? Because it's going to be rotating about the x-axis. No. Yeah, the x-axis. So we set it in terms of y. Or actually, no. If we're using the x-axis, we use a disk method. Let me go back to my previous problem. Disk method for the x-axis, shell method for the y-axis. Okay, I gotta remember that. Disk method for the x-axis. Let me write that down. Disk method for x-axis, and then shell for y-axis. There we go. So if it's going to be the disk method for the x-axis, we know that the volume is equal to what is the volume? It's going to be pi from 0 to the intercept, which means that I believe if we graph it, you should be able to find out what the intercept actually is. Oh, no. Okay, so it starts from 0, and then x is equal to 2, which gives us the intercept. So it's going to be from 0 to 2. That's very nice. We apply the function, which is x to the power of 3, and then we just square that dx. There we go. Pretty simple. So from the integral to 0 to 3. So then x to the power of 3 times 2 is simply x to the power of 6. X to the power of 6 integrated, which is going to be x to the power of 7 over 7 from 2 to 0. If we apply 2 to the 7th, I believe it's going to give us 128. Yes, 128 over 7 pi. Yay! That was pretty easy. Going over to B, what we need to do is, if it's going to be the y-axis, we need to utilize the shell method, which is going to be 2 pi, the integration of 0 to 2 again, and then we need to apply x to the power of 3, multiply that by x dx. Very simple, you know. After getting the hang of doing these problems, it turns out to be quite easy. I think. I'm not entirely sure. Maybe I'm being too overconfident. Okay, so x to the power of 3 times x is simply x to the power of 4. The integration of that is x to the power of 5 over 5 from 2 to 0, which turns out to be 2 to the power of 5 is 64, I believe. No, 32. So 32, and then times 2 is 64. 64 over 5 pi. Let's confirm. Yep. Perfect. Now, finally for problem C is the x is now equal to 4, which means that it actually does not touch. Or maybe it does touch. I think if I just keep applying, because I do need to look at the function. So I can either use, for C I can use either method. I think what I'm gonna do is just keep it simple. I think I'll just work with the shell method from the integration of 0 to 2 again, I believe. Or maybe this time it's going to be 0 to 4 because of the integration. Or the bounds. The bounds have changed, and therefore I should change the bounds for the integral. Which means that I think it's not too difficult of a problem. I think this is just what it's going to be. So x to the power 3 times x dx. I believe this is simply the problem, which means that the problem boiled down is going to be x. We're going to put 4 to the power 5. So 4 to the power 5 is a little bit more of a longer. So to the power of 5 is 1024 times 2, so 2048 over 5 pi. That's what it says. Let's see if it's true. Now I need to scroll quite a bit for this problem. (7.3) Where is 7.3? There it is. So the first two were correct. The third one is 96 pi over 5, not 2048 over pi or 5. So that's incorrect. So we know that that's not true. I think what we need to do is subtract. If it's gonna be 4, all right? Because let's go back to the function. So that's gonna be 4. It's gonna be a bit of a bigger curve. If we go to Symbolab, let me go to this one. And if I graph this, right? If I graph this problem, which is x to the power of 3, and then y is equal to 4, or x equal to 4. I don't think it ever reaches. Oh, yeah, crap. Okay, it does reach, but like, it's at such a high value to the point where I don't think that's the correct way of solving it. So what we need to do is, instead of multiplying that, or putting the bounds there, what we could do is, we have the same idea, right? Which is going to be x to the power of 3, and then we're going to find the area that's underneath there, because we're going to be rotating about the y-axis. Which means that I think what we can do is, if it's really by 4, then what we could do is, well, that's weird because that should be the correct answer. Volume is equal to 2 pi from 0 to 4, x to the power 3, and then times x. Interesting. Might have to consult that with someone else. I'm gonna skip over that and go on to 31. I don't have much time, so I need to make sure that I'm actually properly doing the other ones. And my battery's getting a little bit low on my laptop. Not too low to the point where it'll die, but